Welcome back, epic gamers. Let's talk about how we're going to solve systems of equations. This is Module 2. This is the next kind of topic I really want to make sure you really understand when you come back to class. And it's how to algebraically and visually with a graph solve systems of equations. Now, a system of equation is pretty much when you have two equations and you're trying to find out when they have the same function height, the same output value. Take a look at the first equation I have right here. Y is equal to 1 divided by 4 with an x plus 2. And then I have my second equation. Y is equal to negative x plus 16. So my first equation, I'm going to go ahead and highlight this one in blue. Close enough. And I'm going to go ahead and just graph this approximately where it's going to be. Let me just go ahead and that seems about right. So I've gone ahead and graphed it in blue like that. My next equation, I'm going to go ahead and highlight this one in orange because it's my favorite color. And we're going to see that because there's a negative in front of the x, it's going to have a negative slope going down. And from here we can see that I've already pre-shaded the dots because I put a lot of effort into doing things once. And we can see that I've still not made the situation a little better for myself because it seems that, let's take a look. This blue line, it has a height of 2 over here, then has a height of 3 over here, then a height of 4, and then I don't really know what the height is, but it's somewhere between 4 and 5. Similar thing with the orange line. Up here it has a height of 14, then it has a height of 11, somewhere over here it has a height of 7, but I don't really know what the height of this function is. So here is where both of these functions have the same height. If I were to go ahead and draw a line going off like this, it's somewhere between 5 and 4, but that's not a perfect line that I've drawn. And where even are they the same height in the x-coordinate? If I do my best to draw a line going down, well, it's somewhere past 11, just before 12 on the x direction. I have no idea where these two lines intersect. And that sucks. Because if I want to find out where these two lines have the same y height, the same height, then drawing a graph isn't going to be really helpful. It's not going to be great. It's not going to be an amazing use of my time. Because I've gone ahead and actually spent 5 minutes making this nice graph, portioning it out, figuring out what equations I'm going to draw, and then drawing them. And I am not any closer to having a solution. So let me go ahead and show you the first method to algebraically solve systems of equations. This is what I'm going to call the equal values method. And I say what I'm going to call it because that's what your book calls it. So you're going to call it that too, whether you like it or not. And the equal values method, this works best. This works best when you have two equations in slope-intercept form, in y equals mx plus b form. And if I can write correctly without making any mistakes, that would be amazing, wouldn't it? So if you have two equations of the form y equals mx plus b, then you're gonna love the equals value method. It's gonna be great. It's gonna be amazing. The first step is to set both equations equal to each other. Now, what the heck does that mean? My top equation was the one that I had in blue. The bottom equation is the one I had in orange. And what I'm going to do is I'm going to do something a little bit abstract. So here, y is equal to 1/4 x plus 2. And down here, y is also equal to negative x plus 16. Now if y is equal to all this stuff in blue, and y is equal to all this stuff in orange, what I'm going to go ahead and do is just set them equal to each other. 1/4 x plus 2 will be equal to negative x plus 16. So what I've gone ahead and done is the stuff from the top equation, I went ahead and put it on the left side of the equal sign. The stuff from the bottom equation, I went ahead and just put that on the right. Top equation goes on the left, bottom equation goes on the right. And I'm going to do my best to keep that convention going for the entire course. And then from here, all I got to do is just solve for x. So my first step is going to be adding x to both sides of these equations. We know this x will cancel out with that one over there. And then using your calculator or using your brain power, 1/4 x plus x is going to be 5.25 x plus 2 is equal to 16. And then from here, I'm going to go ahead and just subtract that 2 over. This positive 2 and negative 2 will cancel out, and then I'll be left with 5.25x is equal to 14. And then last step is to go ahead and pull out your calculator. Make sure that I didn't make myself a fool, and confirm that 1/4 plus 1 really is. I am such a fool. It's not 5.25, it's 1.25. Dang it. And then from there, how do you solve for x in this equation? Just divide by 1.25 on both sides. And then from here, x is equal to 14 divided by 1.25. 11.2. And so we can see from our graph that my guesstimation was approximately correct. I knew that they intersected horizontally somewhere past 11. But here's the thing, we're not done yet. We need to find out what the height is. The next thing I'm going to say is the most important thing for this chapter that you weren't here for. The solution to a system of equations is where two lines intersect. The solution is going to be a coordinate pair x, y. And that coordinate pair is going to be where these two lines intersect. You could have a lot of students, do this stuff really well, but they don't even make that connection. They don't realize what they're doing. If you tell them solve a system of equation, they'll do it. They'll get the right answers. But if you ask them, well, what does that mean? This is what it means. The solution to a system of equations is where two lines intersect. And because our answer is going to be a coordinate pair x and y, we only have the x. We're not done yet. We need the y coordinate. And so from here, what you're going to do to solve for the y coordinate is, hey, look at that. This equation tells you what y is. So does the bottom one. What I'm going to go ahead and do is take this answer that we got solving for x, and I'm going to substitute that into the top equation. What does that mean? What I'm going to go ahead and do is just write in that equation. Let's see, 1/4 parentheses 11.2. Close that parentheses. Do not forget your parentheses. I'll make you repeat it 100 times if you forget your parentheses. Plus 2. Just go ahead and hit enter, and then boom. Now we know what our y value is. 4.81. Now what I want you to do is I want you to always use the top equation to solve for y. Always use the top equation. Later we're going to find out exactly why I'm saying that. But for now, just take my word for it. Believe me later. Use the top equation to solve for y. And then boom, this is your answer. X equals 11.2 is not your answer. I shouldn't have put that in a box, but I did on accident. The actual answer is 11.2, 4.8. This is where both of these two lines intersect. That is the solution to this system of equations. Now notice what we did over here is I turned a fairly complicated two-dimensional problem, because these lines, really any two lines, can intersect anywhere in this coordinate plane. These two lines just happen to intersect right here. But what if there was a green line that I was trying to solve for? That goes off like this. Well, if I wanted to find out where it intersects with the blue line, if I had enough space, I can draw it out to infinity, but if I run out of space, then that sucks. Like I can't. Oh, come on. Where was I? I don't even know. The key idea is that we have this complex two-dimensional problem where you have two lines that can intersect anywhere in this complex on the coordinate plane. It really doesn't. It can be in the positive quadrant over here. It could be somewhere over here on the left, somewhere all the way down here in the negative side. I don't know. Every single situation is going to be different. But what we've gone ahead and done using the equal values method is we have turned this complex two-dimensional problem of where these two lines intersect anywhere on this piece of paper, and we have decomposed it into a two-step, one-variable problem. Check it out. I mean, look at this equation we even have over here in color. I mean, if I were to go ahead and just copy this over to a new page, we have 1/4 x plus 2 is equal to negative x plus 16. You know how to solve that. This is not a hard equation to solve. How would you solve, for example, 2x minus 1 is equal to 4x plus 3? It's the exact same process you would solve this one up here. And that's another key takeaway from the second semester of IM1 with Mr. Lopez. Our goal in geometry, in systems of equations, and in exponential functions that we're going to learn in a little bit. Our goal is to turn really complicated problems into things we know how to solve. You know how to solve this. This I go as far as to say as it's easy. This is the only new thing you're learning. Setting these two equations equal to each other. That's the only new thing you've learned. The rest, you know how to do. But what happens if we get some problems that aren't in a nice kind of, let me go ahead and show you what I mean. Y is equal to 2x plus 4. And then another equation in standard form, x minus 4 is equal to, minus 4y is equal to 10. What happens if we have something that looks like this? I'm going to go ahead and tell you the shortcut right now because it seems like the alarms for the school is going to turn on soon, and I don't want to activate and call the fuzz because I sat here too long. Y is equal to all of this stuff. So in the substitution method, we're going to substitute the y in the bottom equation, or the top equation if I wrote this the other way around with the standard form on top. I'm going to replace this y down here with the entirety of the top equation. And what I do when I do that is combine them. X minus 4, do not forget your parentheses, equals 10. And then take a look at that. Once again, we have decomposed a complicated two-dimensional problem into a multi-step equation with one variable. You know how to solve this. You go ahead and distribute. My next step here will be x minus, what is 4 times 2? 8. X negative 4, or 4 times 4 is going to be 16. That minus sign is going to follow us, equal to 10. This you know how to do. All you got to do is combine like terms. Negative 7x minus 16 is equal to 10. From here I'm going to add 16. That negative 16, positive 16 cancel out. And then I have a negative 7x is equal to 26. And because I came up with these problems on my own, just now in my head, I'm going to have a number that's not going to be a nice whole number. 26 divided by negative 7. X is equal to negative 3.71. Now what am I going to do? I'm going to take this answer that I got for the x coordinate of where these two lines intersect, and then go ahead and just shove it into the equation in slope-intercept form. Y is equal to whatever this is. You know what x is, so replace what x is in the top equation with the answer you got right here. And so the next thing I'm going to do is just, well, type that in the calculator. 2 parentheses, negative 3.71, close my parentheses, plus 4. Negative 3.42. And so my coordinate pair answer for the system of equations is negative 3.71 for the x coordinate, and then negative 3.42 for the y coordinate. Put a box around that. And then boom. We have decomposed a complicated two-dimensional problem into one that we know how to solve. And that is our goal for all of IM2, really. How do we transform all these complicated problems into stuff that looks like this? There's a third method called elimination, but I am actually concerned about accidentally setting off the alarms for the school. I'll attach a Khan Academy or something. Elimination method. I'm going to reteach that anyways, because we did a quick start a few days ago and no one knew how to do it. It was about elimination. So it seems I got to reteach that. Any questions, just go ahead and email me. Send a letter to my mailbox here at the school. Carrier pigeon, I accept Visa, MasterCard. I got everything. AT&T, Verizon, Xbox 360. No, that's a lie. I don't have the Xbox. That's it. Heading out. End of Module 2. I'll hand these to you when the person's going to hand you their classwork.